In this video, we're going to continue from our previous video on solving rational inequalities. So example 2, part D, we have 1 over x squared minus x plus 1 over x is greater than 5 over x squared minus x. So again, we're just going to take the previous videos from example 1 and make them inequalities. But again, in general, we treat an inequality like an equation. When we solve this equation in example 1D, we got x equals 5 as the answer to this equation, and we said that x could not equal 0 or negative 1 because it would cause the denominator to equal 0 for either of those values. So those are our critical values, 0, 1, and 5. And because 0 and 1 are automatically open circles if they cause the denominator to equal 0, but as far as 5 goes, the solution to the equation, because we have a greater than symbol and not a greater than or equal to, it's going to be an open circle at 5. So we have to test out a number in our original inequality now, a number less than 0, a number between 0 and 1, a number between 1 and 5, and a number bigger than 5. And when we do that, we'll find that numbers between 0 and 1 will work, and then also numbers bigger than 5 will work as well. So as far as our answers are concerned, we have x is between 0 and 1, so x is greater than 0 but less than 1, or x is greater than 5. So any number we pick in these shaded areas, again, will make our original inequality true. Part E, we have 1 is less than or equal to 2 over x squared plus 2 over x plus 1. And again, we treat it like an equation, which we solved in example 1E. We got the solution to the equation to be x equals 2, and we said that we are not allowed to have x equals 0, nor are we allowed to have x equals negative 1, because they would cause the denominator equal 0. So we got negative 1, 0, and 2 as our critical values. Negative 1 and 0 automatically open circle, and then the 2, the solution to the equation, because it's a less than or equal to, we will include the 2 as part of our inequality answer. So that gets a closed circle on our number line. And then testing out a value from each of these 4 areas of the number line, we find that only the values between 0 and 2 make the original inequality true. So our final answer for this is x is greater than 0 but less than or equal to 2. Finally, part F, we have 1 over 3x minus 15 is greater than or equal to 1 over x squared minus 2x minus 15 plus x squared over 3x squared minus 6x minus 45. And we solved the equation part in example 1F, and we got for our equation, we got solutions of x equals 0 or x equals 1. And for our domain, where the denominator would equal 0, we said x is not allowed to equal 5, nor is it allowed to equal negative 3. So we have negative 3, 0, 1, and 5 as critical values. The negative 3 and 5 are automatically open circle because they cause the denominator to equal 0. The 0 and the 1, because it's greater than or equal to, those solutions to the equations, greater than or equal to, we use closed circles there. So this one, there are, 1, 2, 3, 4, 5 numbers we got to test. So testing a number less than negative 3, between negative 3 and 0, etc., we'll find that the values that make the original inequality true are values between negative 3 and 0, or values between 1 and 5. So our final answer here is x is greater than negative 3 but less than or equal to 0, or x is greater than or equal to 1 but less than 5. So, all right, that about does it for this video. Thank you for watching. I'll see you next time.